Hi guys, Tore here. Thought I'm gonna demonstrate some of the memory modules I've been looking at. So there's three modules we're going to just take a quick look at: memory usage, test memory cycle, and devel leak trace. So I just made a small script just to show concept of memory leaks and how to detect them using these modules. So the first thing we're going to look at is actually the test memory cycle. What I made here is just a variable which actually has a child variable that references back to the main variable from inside the data structure. So this is what we call a circular reference. We have the parent object, which has a variable inside it called child, which references its own parent again. So this might be an issue in Perl. The reason is cleanup process for memory usage is reference count. So whenever a variable goes out of scope, it will decrease the reference count of that variable. But if you nest variables like this, we have two variables referencing each other, that logic doesn't work. So the first model, the first test here is that after we created this circular reference, I'm just going to test that this memory cycle module actually works. So this is a subroutine imported by test memory cycle. And its purpose is just to verify that the circular reference exists. So when I run this, I get the circular reference detected in parent. So that's worked well. Then we have something called weaken. This actually tells the Perl that do not count this reference to parent. It's just gonna not count it. And then I test it again, memory cycle OK. It's no circle reference detecting parent after the weaken. So while the variables still exist in this structure, this there is the reference to this variable, or this reference to the variable, isn't counted. So once this falls out of scope, it only sees the parent referencing the child, but not the child referencing the parent. So memory is freed up as expected. But let's test that. So I made a small subroutine, just going to execute basically this 100,000 times. And I'm adding a second parameter to it. It controls whether or not I invoke weaken to it. So you can look at the subroutine down here. And we just test it in a loop. Here we also see the memory usage module that we're going to talk about later. But here you can see the same construct. And depending on whether we set weaken or not, we will execute weaken. And again, we will record the memory usage. We'll make 10 recordings of the memory usage for this run of the loop, so that for every 10,000 iterations, we will get a recording of how much memory does this use. So let's go up. Actually, this is just code. We'll see this here. When I do not issue weekend, you can see that the memory usage increases by 63% during the run of the application. And when I do issue weekend, it does not increase it at all. So I made this basically the same code twice. I was experimenting with what happens when I just have this loop, and when I even further concentrate the memory leak inside a subroutine. to see whether that has any significant difference. So it actually has a little bit of difference. Let me go up here again. So this is the third and fourth test. This is the fifth and sixth. And what it shows here is that when I do the subroutine way of executing this, I get a 38% increase in memory usage contra 63. But when I do use the weekend keyword, then I don't get any memory increase. And if you look here in the last section, I had the leaking sub dump and leaking no leak dump. This is the output of the memory usage module, this one. So what this did is it recorded, I initiated the module, started it, and recorded the memory usage, start. Then for each 10% of execution completed, I recorded again. So you see here I record run and Perl I, so iteration count. So I recorded at 10,000, 20, 30, 40, and so on. And what you see here is the difference between each run. So after the second run, after the first 10,000 iterations, I used 3,563 bytes, I guess, more than before. And you can see that for each 10,000 run, I use approximately the same amount of extra memory. So the memory goes from 93,000 to 129,000. On contrary, when I do this no leak sub, I get this slightly different result. Still do 100,000 iteration and record every 10,000. But you see the difference here. This is the start command, so this is before I do anything. And the difference is 0, 0, 0, 0, 0, 0, 0. So actually I don't use any more memory at all. Not a single byte between each run. So no leaks there, but there is a leak here. And the only difference is whether or not I weaken the circular reference or not. So you can see this executed quite quickly. Well, sure, I didn't try to do this without any modules, but it takes insignificant amount of time to run this. 200,000 iterations of this in total. So, but there was a third memory module, and this is the devil leak trace. And it has been running while I made this video. So you can see this executed in, if you look at this is a time Perl like test T. It executes in less than 0.3 seconds. When I do the devil leak trace, it takes a lot more time to run this. So the leak trace is not something you can use in production. I actually tested it earlier and I stopped it after about 50 minutes. It hadn't produced any result. So, but what I can do, I can cancel this. I can cheat a little bit. I can take this down to say 100. And 100. I can try to start it again. Hopefully now it should run a bit faster. But it doesn't. It's too few runs to actually increase the memory usage. Let's see here. So actually the memory leak test fails because it's too small of amount of difference in the memory usage. But it outputs a lot of different information. And it says I have a memory leak at line 93 and 92 and 125 and 126. So let's look at line 93. There it is. This is the making of the circular reference. So it detects that as a problem. Not sure why it complains about 92, but I guess it's somehow related to this. Also 125 and 126. So this is in the leaky sub, the same lines. So that is how we can use these modules to actually find some issues.